Alright, hi guys.
I'm Arjun.
And I'm Avika.
Okay, so today we are talking about?
Thermodynamics.
Alright, we'll do that in two parts, okay? So to begin with, Avika, do you have an idea what thermodynamics is?
It's the study of heat and motion.
Heat and motion. So what are we mainly dealing with, Arjun?
We're mainly dealing with transfer of energy.
Transfer of energy. Do you know how this all started?
With steam engines?
Okay, so first they made steam engines. Did they know thermodynamics rules then?
No.
Okay,
Then they started started making up rules and actually finding the rules.
Yeah.
And then they realized that they applied to anywhere where energy was transferred.
Okay, that's good. Okay, so now let's talk about a few basic concepts, alright? Before we go into the details. So what is heat transfer?
Heat transfer is...
Avika, do you have something?
Heat transfer is...
So transfer of heat from one body to the other.
Yeah.
Do you guys know the different ways it happens?
Conduction.
Conduction, convection, and radiation.
Alright, what do you know about conduction?
Conduction is whenever energy is moving through a solid.
Through solid. Do you know how it happens?
It happens because all the molecules are tightly packed. So whenever they vibrate,
so when you give energy, it vibrates.
And then they move. The one vibrates, and then that makes the other one vibrate, and that makes the other one vibrate.
That's how the energy is transferred, right? So when the energy is transferred, the molecules move and measure of... Arjun, you want to say more about that?
Yeah. So whenever it's transferred, the molecules move,
we'll talk about what that means in the later section. Okay. So how about convection, sweetheart? Do you know?
It's whenever energy is moving through a liquid.
Liquid. So how does that happen?
It happens when so the molecules are not as tightly packed.
Correct.
So they go.
You want to take it, Arjun?
Yeah. So they're not as...
You got it, Avika. I know you got it. All right.
They're not as tightly packed. So whenever energy is given, it becomes less dense.
Okay, why does it become less dense?
Because...
So when you give heat or energy, they start moving around.
Yeah, they start moving around.
They're loosely packed, so they move around, they push the boundaries, so they become less dense.
Yeah,
Good.
they go upwards, and so then the more dense ones up here come down to the source of heat.
And then, this way the molecules... The liquid itself transfers energy. Okay, good.
You can see that in an experiment if you put water
and you heat it and put little piece of paper in.
You see that circulating.
Yeah,
very good, very good. Awesome. Well, what is the other one?
Radiation.
Radiations. What is that?
Whenever energy is moving through air or
open space.
Through empty space. Okay, empty space. It's not going through any medium. Okay. So can you give an example where all three happen together?
The sun.
Okay, tell me how.
So in the core, it comes out through conduction and radiation. And then in the outer layers, it's absorbed by the gases. Through convection.
Correct.
And then whenever they escape out, it's radiation into the open space.
That's awesome. Alright, let's talk about heat capacity. Do you guys know what heat capacity is?
Yes.
Go ahead.
So heat capacity is how much
heat it takes to change the temperature of...
For given amount of a substance, correct? That's awesome. That's the heat capacity, right? So what is specific heat?
It's whenever you're raising it by 1 degree per 1
kilogram. Correct? Okay. Do you know a substance that has very high specific heat or heat capacity?
Water.
Water. So how does that help?
Because we use it as a coolant for where we're really hot.
Yeah. So where it it has a capacity to absorb a lot of heat, correct?
Before
So that's
it
what.
gets hot.
Yeah.
So another example of that is in
Uh-huh.
sweat. It uses.
Yeah.
Comes in it.
So tell me more about that. So when your body gets hot,
When your body gets hot, it produces sweat, and so that absorbs energy.
that has a heat capacity, so it takes up heat, and then when it evaporates, we'll talk about that again, right? All right, that's latent heat, correct? So that's the body's mechanism to cool you down when you get hot, because we are warm-blooded, right? So our bodies want to be in specific temperature. You guys know why we have to be in specific temperature? What happens if we get too cold or too hot? We'll talk about it another day, okay? There's many enzymes which stop working. Alright? Alright. So let's now back to thermodynamics. Latent heat. What do you guys know about latent
So
heat?
latent heat is how much energy is needed to break the bonds in a substance or form them up.
Okay. That's awesome. So it is got to do with change in
state.
change in states or change in forms,
But
right?
it doesn't heat anything or
It doesn't change the
It
temperature
changes.
itself.
It
Okay,
doesn't
how
change
many
the
kinds of latent heats do you guys know?
So there's latent heat of fusion.
and then heat of vaporization.
Very good, Aviku. Excellent. You want to tell me what latent heat of fusion is?
Latent heat of fusion is whenever ice is turning into water.
Okay.
It's taking up energy
Okay.
to break the bonds.
Okay, so 0-degree ice
Yeah.
changes into 0-degree water without changing temperature, but it has absorbed energy. Where did that go?
Into
To?
breaking the bonds.
Correct. That's latent heat of fusion. What about latent heat of vaporization? You know what I'm saying?
So it's whenever water is changing whenever it's vaporizing, like
100 degrees of
Yeah.
water becomes 100 degrees of vapor. Energy is absorbed to change the form. Excellent, excellent. And that's how also sweating uses the latent heat and cools our body, right? Okay, let's talk about measuring temperature. So when you say we are measuring temperature, what exactly are we measuring?
we're measuring the average kinetic energy of the molecules.
Correct. So you remember in conduction, when something vibrates,
Yeah.
it transfers to others. So that's what we are measuring as temperature, right? So all molecules are moving at different kinetic energies.
Yeah.
So we are trying to measure the
The average.
correct. All right. So which was the first scale of
The
temperature?
first scale was Fahrenheit.
Okay. So how did they come up with what was 0 and what?
Okay, so
Okay, go ahead.
I
Avika.
think one scientist,
Yeah, his name is Fahrenheit.
yeah,
Okay.
and he tried to make the coldest he could
In the
in
laboratory,
the
right?
laboratory, with salt and things like that.
Yeah.
And he said that was 0.
So whatever coolest temperature he could achieve in the laboratory, he called it 0.
Yeah.
Correct? But what was the problem with that? Go ahead.
the problem with that is that the water's freezing point is 32 degrees Fahrenheit
And the boiling
and the
is
boiling is 212. So it's an awkward number.
180 degree,
Yeah.
180 degrees difference, right? So with Celsius, what did they take the frames of reference?
So
They just made 0, the
Yes.
freezing point of water,
Correct?
and the boiling point of water 100.
Perfect. You guys know any other scale?
Kelvin.
Yeah, we'll come to that again, okay? So how do we measure temperature? What do we use? What principle do we use?
we use metals that
That expand
whenever it's hotter and
that
contract.
contract.
Yeah, but more modern equipments used properties such as conductivity and resistance. We'll come to that later, okay? All right, now back to the third unit of temperature, Kelvin, right? So what is Kelvin scale and what is 0 in Kelvin scale? What is that called?
0 in Kelvin scale is called absolute 0
Why is it absolute?
because that's when the
that's
molecules
when everything
completely stop
Stop
moving.
moving.
There's
Yeah, so
no
we are
kinetic
trying to
energy.
measure average kinetic energy when they completely stop
There's no kinetic energy.
and and it cannot go any further lower than that. That's why it is an absolute zero. Awesome, guys, awesome. And how many degrees is that?
That is minus 273.15 degrees Celsius.
Good job, you guys. Really awesome. So, have they been able to achieve that in the lab?
No,
they haven't
but
been
they
able.
got 1/2 of a billionth
Above the zero, right? 1/2 of a billionth degree,
Really close.
just above absolute zero. Yeah, that's pretty close, huh? All right. So, I think we'll stop here and then get back to heating, or we can do heat engines and pumps. Okay?
Okay.
Okay, let's see. Can you guys tell me about heat engines and pumps?
So heat engines
It
is
says
transferring
heat
energy into
a
mechanical.
mechanical energy.
Now, what
And
about heat pumps?
Heat pumps do the exact opposite.
Opposite, like
changing mechanical energy into heat.
what? Heat energy. Okay. Can you just run it really quick? How heat engines work?
So a gas, a liquid
Mm-hmm.
is heated up, and so the pressure increases,
Okay.
and then it turns this turbine
So the increase in pressure is converted to
Yeah.
mechanical energy.
energy.
Turns the
turns the
turbines or
turbine.
whatever.
Then
Okay.
it goes into a condenser.
What goes into condenser?
The gas
Correct.
goes into the condenser, and it gets turned back into liquid,
Yeah.
and then it goes on
Goes
the
through
cycle
the
again.
cycle. Yeah, it takes the advantage of change in forms, right? That's awesome. And how about heat pumps? Say refrigerator. How does that work?
So that
Mm-hmm.
uses the heat
Mm-hmm.
to vaporize water.
So it absorbs heat
Absorbs heat.
from inside of the
From inside of
refrigerator,
the
and it vaporizes a liquid to gas. Then
Then it changes that back into a liquid.
compresses it
Yeah,
back.
compresses it back.
So when it compresses, what happens?
There's heat, and that comes out.
It is released outside,
Yeah.
and you get
Yeah,
felt
we
it
saw
near
that.
near our
there.
wine cooler, right? Okay, good job. I think we will stop it here and then resume back on enthalpy, entropy, laws of thermodynamics, arrow of time, and concepts like that. Okay.
Maxwell's demon.
What is that? Oh,
Maxwell's-
Maxwell's demon. That's right. That's interesting. We'll get back to that in the next part. Okay. Awesome. Good job, you guys.